Hi guys, this is Gautham from Mechanical Department. My registration number is 24BME1033 and I have brought a sum from Hibbles book in the topic of equilibrium of two rigid bodies in two dimension. So the question is, if the intensity of the distributed load acting on the beam is 3 kN per meter, that's given as W, then determine the reactions at the roller A and pin B. So this is the figure. Here's the roller A and here's the pin B. So first let's draw the free body diagram. Before that we can add it. This has 3 kN per meter. So now let's draw the free body diagram. So this will be the point A, and this will be the point B. So the reaction force, we can name it as R of the load on the beam. This is the reaction force of the load on the beam, and since B is a pin, we can have two reactions acting along this point. So By dx. So since this is the roller, we will have one reaction acting towards the point, so this will be A. So while taking the components, this will be A sine 30, since this is 30 degrees, that is given in the figure. So this will be A sine 30 and this will be A cos 30. So this distance is 3 meters. So this distance, then this distance will be 3 sine 30. This will be 3 cos 30. So, and then this is given as 4 meter, that is fixed. Since the reaction acts on the midpoint, this will be 2 meter. So now let's calculate the reaction force. The reaction force R of load on the beam is equal to the W which we calculate, which was the W which was given in the question, into the perpendicular distance. So this will be 3 kilonewton per meter into 4 meter, and this results in 12 kilonewton. So we can use it as 12 kilonewton. Now we have to determine the reactions at A and B. So first we will take the moment above the B point. So summation of moment B is equal to 0. So A sine 30, this rotates in the clockwise direction, so this rotates like this. So we will put minus A sine 30 and its perpendicular distance will be this one. So into 3 sine 30 plus, now for this component A cos 30, this also goes through the clockwise direction, so it also attains negative direction, and A cos 30 into the perpendicular distance of this will be 3 cos 30. This will be its perpendicular distance, so this will be 3 cos 30 plus 4 meter. So 3 cos 30 plus 4. Then the other reaction will be R, so plus R into its perpendicular distance to B is 2 meter, so 2. Since these both are already present at the B point, this both will be 0, so it is not needed to be taken in here, so equate it with 0. Now the normal mathematics, this will be, so take the A as common, so minus A into sine 3 sine square 30 plus 4 cos 30 plus 3 cos square 30 plus r is 12 into 2, so this will be a into 6.464, that's equal to minus 24. As this 12 into 2 is 24, this goes to this right side, then it will become negative. Now the negative sign at the each side will be cancelled, so a will be 24 by 6.464. this gives you 3.713 kilonewton. So now we have attained the reaction at the roller A point. Now let's find for the pin B. So we'll equate the forces along the x-axis. So f of x, summation of f of x is equal to 0. So this will be according to the free body diagram, a sine 30. So we can equate a sine 30, then the bx force. So this will be a sine 30 plus bx. Since both are going towards the right direction, both will be positive. So a we found, and it was 3.713 sine 30, and bx we have to find. So bx will be minus 1.857 kilonewton. So this sign, negative sign, indicates that we have took the wrong direction of the component. So now we have to change the direction of the component, so then it will become 1.857 kilonewton. So let's change it here. So this will be wrong, and we should be taking it as bx. So the direction will be towards the left side and not towards the right side. So we found bx. Now we should find by, so that we can equate all the y forces acting along the y direction. So summation of f of y is equal to 0, and that will be a cos 30 minus 12, which was the reaction that was acting downwards, and plus by, that's equal to 0. So a cos 30 will be 3.713 cos 30 minus 12 plus by to 0, and by will be 12 minus 3.713 cos 30, and at last we will get, by calculating, 8.784 kilonewton. So since this doesn't have the negative sign, we can say that we assumed the direction of the by component as the correct direction. So now we doesn't need to change the direction of the by. So as we conclude that, we found the reaction A at A will be 3.713 kilonewton, and reaction at B will have two components, and that will be bx is equal to 1.857 kilonewton and by will be 8.784 kilonewton. Thank you.